Yes. So now we are discussing about the model. Previous slide we already discussed about the machine learning concept, intelligence concept. We already discussed about the type of machine learning techniques like supervised learning, unsupervised learning, reinforcement learning technique. So let's discuss about the model which are considered under the supervised learning and unsupervised learning technique. So firstly, we discuss here Naive Bayes classifier, Naive Bayes classifier, or you can say Naive Bayes model, Naive Bayes algorithm. So Naive Bayes algorithm is a supervised learning algorithm which is based on Bayes theorem. We already know about the Bayes theorem. Uh, we learned this thing, Bayes theorem, at 10th standard level at the time of schooling. So this is Bayes theorem and used for the solving classification problems. It is mainly used in text classification that includes a high dimensional training data set. Naive classifier basically used for which purpose? Text classification purpose. Okay, that may be included as a high dimensional training data set. Naive classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning model that can make predict quickly. It is a probabilistic classifier. You can say probabilistic classifier because it is based on the Bayes theorem. That means you can say probability is there involved there. Okay. So which means it predicts on the basis of probability of an object. Okay. Probability is also discussed. Probability is also learned in 10th standard schooling time. So I hope uh, you all learn about this probability at the 10th standard. So, but we will discuss about the formula of probability and Bayes theorem also in the next slide. Some popular example of Naive Bayes algorithms are spam filtration under the category of classification. Okay, sentiment analysis. Sentimental analysis, that means, for example, if you want to purchase any product from the Flipkart. For example, if you want to purchase Apple phone or MI phone or Samsung phone, but if you want to search any particular product with product name on the Flipkart, so that will be suggested any other product also and this product also with other customer sentiments about the sentiments of that particular product. Okay, what is the features of that particular product? Other customer who are using that particular product, they discuss about the features of that particular pros and cons of that particular product. Okay, and the classification of the article also. Okay, why it is called naive bias? So naive bias is comprised of two words, naive and bias, which can be described as first one is naive. It is called naive because it assumes that the occurrence of certain features is independent of the occurrence of the other features. Okay, assume that the occurrence of the certain features is independent of the occurrence of the other features. Okay, that's called as the probability. Okay, such as if the fruit is identified on the base of the color, shape, taste, then red, spherical, and sweet fruit is recognized as an apple. Hence, each feature individually contributes to identify that it is an apple without depending on each other features. Okay, so that is the concept. Okay, bias. It is called bias because it's depend on the principle of Bayes theorem. Bayes theorem means what? this one. Okay, I already told you, and this is the basic theorem we already discussed in 10th standard schooling time. Okay, so Bayes theorem is also known as Bayes rules, Bayes law, which is used to determine the probability of the hypothesis based prior knowledge. It depends on the conditional probability. Okay, the formula for Bayes theorem is given as you can see here. The probability of hypothesis A on the observed event B is equals to the probability of the probability of hypothesis B on the observed event A multiplied by probability of A and divided by probability of B. This is the formula of Bayes theorem, where probability of A probability of hypothesis A on observed event B is the posterior probability. Okay, the probability of hypothesis B on observed event A is likelihood probability. Okay, this probability of evidence given that the probability of a hypothesis is true. Okay, so P of A is the prior probability and P of B is the marginal probability. You can say probability of evidence. P of A, that means probability of hypothesis before observing the evidence. And P of B is the marginal probability, which is called the probability of evidence. Remember all these things. P of A on B, P of B on A, P of A and P of B. What are these things? Okay, remember these things. Working of the Naive Bayes classifier. Working of the Naive Bayes classifier can be understood with the help of following example. We are discussing one of the example. Suppose we have a data set, weather condition and corresponding target variable will be play here. Okay. So using this data set, we need to decide that whether should play or not on particular day according to the weather condition. Okay. So solve this problem, we need to follow the following step. First one is convert the given data set into the frequency table. First step is we are discussing here how working of Naive Bayes classification model. Okay. So firstly, we convert the given data set into frequency table. Okay. Second step is generate likelihood table by finding the probabilities of given features. And third one is use Bayes theorem to calculate the posterior probability. Okay. So what is the problem here? If the weather is sunny, then players should play or not. Problem is, according to the data set, problem is here, if the weather is sunny, then the players should play or not. Okay. Solution will be here. First step is firstly analyze your data set. There is a weather data set. There is the weather condition data set here. There are three features: outlook, play, and play condition yes or no. Okay, so we need to identify here where the the weather is sunny, then player should play or not. Okay, so first one is outlook, second one is weather, and third one is play. Okay, there are three features. Okay, there is a uh, some mistake here. First column is outlook, second one is weather, and third one is play condition. So firstly, we need to observing the data set. Okay, and second one is we need to create here frequency table for that given data set. So we need to calculate here frequency table. There are the frequency table here. Okay, so first column is representing weather condition. Okay, there are three condition here: overcast, rainy, and sunny. Okay, and there are two condition, play condition, yes or no. There are two condition here, yes or no. So we need to calculate here according to the data set. Okay, according to the data set, there are three weather condition here: overcast, rainy, and sunny. Okay, so overcast. First is overcast. So we need to calculate how many members said here at the time of overcast we can play tennis player. Okay, so there are five. We can calculate from this. Okay, overcast one, two, three, four, and five. That means five members are interested to play the game at that weather condition is overcast. Similarly, how many candidates said no? We cannot play at the time of overcast condition. Okay, so we need to calculate here. Count here zero. There is no one can. There are no one said saying here we cannot play the overcast time uh, playing condition. Okay. Second one is rainy. Similarly, we can counter the time of rainy weather. We can play the game or not. So first one is yes here at the time of rainy. Second one is yes here, and two are the no. Two are said no. We cannot play the game. Two said we can play the game, and two said we cannot play the game. Similarly, we can calculate for the sunny weather condition. Three said we can play the game, and two said that we cannot play the game. So total, how many say yes for all weather condition? Total 10. Okay, and how many no? Total 4. Sorry. Okay, I think forecast maybe one here. Who said no? Okay, okay. You can assume here one. Okay, because here the all calculation on the basis of this point 5. Okay, so you can calculate here one. Okay, so next step is likelihood table weather condition. We can calculate here with the help of frequency table. Okay, so weather, similarly weather first column is here. Sorry, weather, second one is no, third one is yes. Okay, so overcast, we need to calculate here likelihood table for the overcast weather. How many said no? Zero. How many said yes? Five. Okay, so how many said yes? Five. And no? Zero. That means 5 plus 0, total 5. So 5 upon 14. 14 total. Total member is 14 here. This is, you can correct here. It's 4. It's a number of 4. Okay. So 5 upon 14 is equals to 0.35. Similarly, we need to calculate here likelihood value for the rainy season. How many said yes? How many said no? 2. How many said 2? Yes, 2. Total is 4. So 4 upon 14. 14 means total value. Okay. So 4 upon 14 is 0.29. Okay. For the sunny, similarly we calculate 0.35. How many said yes? Total count here 5, 2, 7 plus 3, 10. 10 upon 14 is 0.71. Similarly calculate for no. 4 upon 14 is 0.29. Okay. Now, applying Bayes theorem on the given likelihood table. Okay. Given data. So we need to calculate here probability of yes on sunny weather. So there is the formula, probability of yes over sunny is equals to probability of sunny over yes multiplied by probability of yes upon probability of sunny. We just use this formula here. Okay, this one. Okay, so similarly, again, apply this value. Put this value in this given formula, and you will get the answer for probability of yes over sunny. Okay, so probability of sunny over yes. We already calculate here 3 upon 10 is equals to 0.3. Okay, probability of sunny over yes. Probability of sunny 0.35. Okay, probability of yes 0.71. Okay, 0.71 probability of yes 0.71 probability of no 0.29. Okay, probability of sunny for yes 3. How many total? 10. Okay, so that is why we put here for this particular calculation probability of sunny over yes. Okay, so total of yes is 10. We need to calculate for sunny. Total is 3. So 3 upon 10 is equals to 0.3. Okay, probability of sunny is equals to probability of sunny is equals to 0.35. We already calculated here. Okay, 0.35. Just put it here. Okay, probability of yes. We already calculated here 0.75. Okay, so just put it the value in this given formula, and you will get the answer probability of yes over sunny is equals to, just calculate here and we will get the value 0.60. Okay, similarly you need to calculate here probability of no over sunny is equals to probability of sunny over no multiplied by probability of no divided by probability of sunny. Okay, just put it all values in this given formula. For example, no probability of sunny, how many sir? No, 2. Total is 4. Okay, so 2 upon 4 is equals to 0.5. Probability of no is equals to 0.29. We already calculate here in the previous slide. You can see here. Okay, probability of sunny is 0.35. We already calculate here. Okay, so we need to put all these value in given formula. You will get the answer 0.41. Okay, so as we can see from the above calculation that p probability of yes over sunny greater than probability of no over sunny. Okay, probability of yes over sunny weather greater than probability of no over sunny weather. Hence, we can say on a sunny day, player can play the game. Okay, so that is the concept of Naive Bayes classifier. Okay, that is the basic example to understand how can we how Naive Bayes classifier works. Okay, because whenever you do the programming on the any programming tool, just put the Naive Bayes, just import the Naive Bayes classifier. Okay, so firstly we need to know how it is work. Okay, there are some advantages of the Naive Bayes classifier. Naive Bayes is one of the fast and easy ML algorithm to predict a class for dataset. It can be used for binary as well as multi-class classification. It performs well in multi-class prediction as compared to the other algorithm also. Okay, it is the most popular choice for text classification problem. There are disadvantages of the some disadvantages of the Naive Bayes classifier. Naive Bayes assumes that all features are independent or unrelated. So it cannot learn the relationship between features. Okay. Application of Naive Bayes classifier. Application of Naive Bayes classifier. It is used for credit scoring. It is used in medical data classification. It can be used in real-time prediction because Naive Bayes classifier is a larger agar learner. Is a learner. It is used in text classification such as spam filtering and sentiment analysis. These are the basic application where we used Naive Bayes classifier. Okay, type of Naive Bayes model. There are three type of Naive Bayes model which are given below. First one is Gaussian model. The Gaussian model assumes that features follow a normal distribution. This means if predictor takes continuous value instead of discrete value, then the model assumes that these values are sampled from the Gaussian distribution. Okay. Second one is multinomial. The multinomial Naive Bayes classifier is used when the data is multinomial distribution. It is primarily used for document classification problem. It means a particular document belong to which category such as sports, politics, education, etc. The classifier uses the frequency of words for the predictors. Okay, and last one is Bernoulli classifier. The Bernoulli classifier works similar to multinomial classifier, but the predictor variables are the independent Boolean variables, such as if a particular word is present or not in the document. This model is also famous for document classification task. Now, second model is SVM. You can say support vector machine. Support vector machine or SVM is one of the most popular supervised learning algorithms, which is used for the classification as well as recreation problem. However, primarily it is used for classification problem in machine learning model technique. The goal of SVM algorithm is to create the best line or decision boundaries that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. Okay, SVM model is to create the best line. Best line. There are so many lines are there. So many decision boundaries are there. But SVM model select the best boundary line. That's called the hyperplane. Okay. For that purpose, for which purpose? To segregate n-dimensional space into classes so that we can easily put the new data whenever arise new data in that model, that new data point in correct category, we place that in the future. Okay. SVM choose the extreme point, you can say vector that help in creating the hyperplane. Okay. SVM select some point, or you can say vector, extreme points or vector. You can see here there are 2 points here, extreme point which is nearby the decision boundary line, this one and this one. These are called the support vector. Okay. On and this is the maximum margin hyperplane, you can say decision boundary. Okay. And the nearby there are two extreme hyperplane. One is the positive hyperplane, which is uh, which is extremely nearby one of the support vector, and another one is negative hyperplane, which is also extremely nearby the other support vector. Okay, and there are some space between positive hyperplane and negative hyperplane. That's called the hyperplane margin. Okay, that is the reason this algorithm is named as support vector machine, because this model works totally depends on the support vector. Okay, uh, consider the given diagram. You can identify the which are the support vector, which are the decision boundary, which are the positive hyperplane, negative hyperplane, and these point are the uh, uh, these points are under the category of class 1, and these point under the category of class 2, and x1 and x2 are representing the features. Okay, so hyperplane and support vectors in the SVM model or algorithm. Hyperplane, we already discussed about hyperplane and support vector in this diagram, so you can easy to understand this thing. Hyperplane, there can be multiple lines, we already said, or you can say decision boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundaries that helps to classify the data points. This best boundary is known as the hyperplane of the SVM. The dimension of hyperplane depend on the features present in the dataset, like x1 or x2, okay, in this diagram, which means if there are two features, then hyperplane will be a straight line. And if there are three features, then hyperplane will be a two-dimension plane. We always create a hyperplane that has a maximum margin, okay, which means the maximum distance between data point. You can say data point, that means at least you can consider these support vector data points. Okay, okay. Next one is support vectors. The data points or vectors that are the closest to the hyperplane and which affect the position of the hyperplane are termed as support vectors. Since these vectors support the hyperplane, hence called the support vector. These vectors support the hyperplane classify to classify the two classes, more than two classes. Okay, with the help of support vector, we can make the classes. Okay, you can classify the data points. That is that's the support vector. How does SVM works? The working of SVM algorithm can be understood by using an example. Suppose we have a data set that has two tags, green and blue. You can see in this picture, and the dataset has two features, x1 and x2. We want a classifier that can classify the pair x1 and x2 of coordinates in either green or blue. You can see this picture. Here are two straight line here. So it is a two space. So by just using a straight line, we can easily separate these two classes, but there can be multiple lines that can separate these classes. Okay, you can see here there are two classes, blue and green. Okay, with the help of this line, decision boundaries, you can say. How does SVM works? This is the picture. This is the support vector, this one and this one, which is nearby, extreme nearby by the uh, this is a positive and negative hyperplane, and calculate the maximized margin. Okay, calculate the maximized margin. Hence, the SVM algorithm helps to find the best line or decision boundaries This best boundary or region is called hyperplane, and you can say optimal hyperplane. Okay, SVM algorithms find the closest point of the lines from both the classes. These points are called the support vector, and the distance between vectors and hyperplane is called as margin. And the goal of SVM is to maximize this margin. The hyperplane which with maximum margin is called the optimal hyperplane. Non-linear SVM. If data is linearly arranged, then we can separate it by using a separate line, as discussed in earlier slide. But for the non-linear data, we cannot draw a single straight line. Consider this image. How can we classify it? Okay, at the time of non-linear data. So, to the separate these data point, we need to add one more dimension. For linear data, we have used two dimension x and y. So, for nonlinear data, we will add a third dimension z. It can be calculated as z is equals to x power 2 plus y power 2. Okay. By adding third dimension, the sample space will become like this image. Whenever add z dimension, so there will be the third dimension with nonlinear data. Okay. So now SVM will divide the data set into classes the following ways. Consider the given image. You can see here, this is the best hyperplane for the particular non-linear data. This is the best hyperplane. There are three classes, first one, second one, and third one. But these are the same. So you can see here, this is the best hyperplane. Green consider as a single class, and remaining blue consider as a other class. Since we are in third 3D space, hence it is looking like a plane parallel to the x-axis. You can see this image. Okay, if we convert it into 2D space with z is equals to 1, then it will be become as this. Hence, you will get circumference of radius 1 in the case of non-linear data. Circumference will be 1 for the non-linear data. Okay. There are some advantages of the SVM algorithm handling some small data set. SVMs can perform well with the small data set as they only require a smaller number of support vectors to define the boundaries. Second one is modeling nonlinear decision boundaries. SVMs can model nonlinear decision boundaries by using the kernel trick, which map the data into higher dimensional space where the data can become linearly separable. Next one is robustness to noise. SVMs are robust to noise in the data as the decision boundaries is determined by the support vector, which are the closest data point to the boundary. Generalization, SVM have good generalization performance, which means that they are able to classify new unseen data as well. Versatility, SVMs can be used for both classification and regression tasks, and it can be applied to a wide range of applications like NLP, natural language processing, computer vision, and bioinformatics. Next one is sparse solution. SVM have a sparse solution, which means that they only use a subset of training data to make prediction. This makes the algorithm more efficient and less prone to overfitting. Okay. Regularization. Regularization SVM can be regularized, which means that the algorithm can be modified to avoid overfitting. There are some disadvantages of SVM algorithm. First one is computationally expensive. SVM can be computationally expensive for large data set, as the algorithm require solving a quadratic optimization problem. Choice of kernel. The choice of kernel can greatly affect the performance of an SVM. It can be difficult to determine the best kernel for the given dataset. Next one is sensitivity to the choice of parameter. SVM can be sensitive to the choice of parameter like a regularization parameter, and it can be difficult to determine the optimal parameter, okay, for a given dataset. Memory intensive. SVM can be memory intensive as the algorithm requires storing the kernel matrix, which can be large for large dataset. Limited to two class problem. SVM are primarily used for two class problem, although multi-class problem can be solved by using one versus one or one versus all strategies. Okay, so these are the some basic disadvantages of the SVM. And another one is lack of probabilistic interpretation. SVM do not provide a probabilistic interpretation of the decision boundaries, which can be disadvantage in some applications. Next one is not suitable for large data set with many features. SVM can be very slow, can be consume a lot of memories when dataset has many features. Not suitable for dataset with missing values. SVM require complete dataset with no missing values. It can not handle the missing values. There are some applications of SVM. First one is face observations. It is used for detecting the face according to the classifier and model. Next one is text and hypertext arrangement. In this, the categorization technique is used to find important information, or you can say required information for arranging text. Next one is grouping of portals. It is also used in the grouping of portals for grouping, or you can say by comparing the piece of information and take an action accordingly. Next one is in bioinformatics. It is also used for medical science as well, like in laboratory, DNA search, and amino acid, etc. And handwriting reimbursement. It is used for handwriting recognition system. And last one is protein fold and remote homology spotting. It is used for spotting, or you can say the classification class into functional and structural classes given their amino acid sequences. It is one of the problem in the bioinformatics. Last one is GPC, generalized predictive control. It is also used for GPC for predicting, and it relies on predictive control using a multi-layer feed-forward network as the plant's linear model is presented. Yes, there are some kernel functions which are used in the SVM. Basically, you can say with the help of kernel function, SVM works. Okay, so kernel function is a method used to take data as input and transform it into required form of processing data. Take as an input and transform it into further process. Okay, so just like a work as an intermediate. Okay, in the SVM algorithms, or you can say SVM model. Kernel is used due to a set of mathematical functions used in SVM, providing the window to manipulate the data, obviously, one form to another form. That means manipulate the data. Okay, this is the mathematical function which is used in the support vector machines. So kernel function generally functions the training set of data so that a nonlinear decision surface is able to transform to a linear equation in a higher number of dimension space. Non-linear decision surface is able to transform a linear equation in a higher number of dimension space just because of kernel function. Okay, basically it returns the inner product between 2 points in a standard feature dimension. Product between 2 points in a standard feature dimension. So standard kernel, there are some equations, there are some mathematical equation which are representing the kernel function. Firstly, we discuss standard kernel function equation. Just you can observe here. This is the uh, equation, standard kernel function equation. Okay. You can just observe here this equation k of x bar is equals to 1 if mod of x less than or equals to 1. That means whenever the features value less than is equals to 1, answer will be considered as 1. Okay, and otherwise 0. That means transformation will be there. Okay, so this is the standard kernel function, and another one is Gaussian kernel. It is used to perform transformation when there is no prior knowledge about the data. Okay, there is no prior knowledge about the data. In that case, Gaussian kernel we can use here. Just observe this equation for the kernel, Gaussian kernel. Gaussian kernel and Gaussian kernel RBF, radial basis function. Okay, so another one is RBF. Okay, first one is standard kernel function equation. Second one is Gaussian kernel. Third one is RBF, radial basis function. Same as kernel function, adding radial basis method to improve the transformation. Just add here little bit new thing, radial basis method, where we can add Gaussian kernel. Whenever we add in the Gaussian kernel equation some radial basis method, so you can say that's called the RBF, radial basis function. Just like this, you just observe this equation. Don't remember this equation, but just know about what is the standard kernel, what is the Gaussian kernel, and what are the RBF. Because these things we will perform in the practical with different kernels. That's why I am presenting here. Okay. Next one is sigmoid kernel. This function is equivalent to a two-layer perceptron model of the neural network, which is used as an activation function for the artificial neuron. This is the equation of the sigmoid kernel, and this is the form of the sigmoid kernel. Okay, and polynomial kernel, it represents the similarity of vectors in the training set of data in a feature space over polynomials. It is representing a similarity of vectors in the training set of data in a feature space over polynomial of the original variable which are used in the kernel. So this is the image, oh sorry, this is the equation of that particular polynomial kernel whenever we used polynomial kernel. So this is the function of the particular polynomial kernel. Okay, and this is the form of the polynomial kernel. Yes, now we are discussing next model, decision tree. Decision tree actually is a supervised learning technique that can be used for both classification as well as regression problem. You already know about the classification and regression problem. We already discussed about this thing. Classification, we already given the example like email spam classification, and we already given the example of regression, weather prediction, stock price, market prediction. These are the problem considered as a regression problem. Okay, so this model will work on the both cases. Okay, but mostly it is preferred for solving classification problem. Mostly, it is a tree structured classifier. That's why it's called the decision tree. Okay, it's follow the tree structure manner, where internal node represent the features of the data set. Internal node represent the features of the data set, and branches represent the decision rules, and each leaf node represent the outcomes. Tree is a combination of node and branches. You all knows. Okay, there are some nodes and some branches. Okay, so we can say here internal node, where the internal node present the represent the features of data set, and branches represent the decision rules, and each leaf node represent the outcomes. Leaf node, that means extreme node, extreme last node. Okay, and you can say child node. Okay, yeah. In a decision tree, where are two nodes, which are the decision nodes and leaf node. Decision node and leaf node. Decision nodes are used to make any decision. Decision nodes are used to make any decision and have multiple branches. Whereas leaf node are the output of those decisions. Leaf nodes are the output of those decisions and do not certain any further branches are there, because these are the last node. These are the child node. Okay. So the decisions or the test are performed on basis of features of the given data set. It is a graphical representation for getting all the possible solution to a problem or decision based on your given condition. So this is the pictorial representation. This is the pictorial representation of the decision tree. Okay, there is a you can see here these are the decision nodes. Okay, and there are some leaf nodes are there. Okay, and this one is the root node. Okay, and this is surrounding with the dashes line. This called as the subtree, and complete will be called as a tree, decision tree. You can say. Okay, so it is a decision tree because similar to the tree. Okay, it is start with the root node, which expand on further branches. These are the branches: left branch, right branch. Okay, and construct a tree-like structure. You can see here there are the nodes and some branches are there. There are the uh, left child node and right child node. There are again connected with the some branches. There are some leaf nodes are there connected with decision nodes. Okay, so this is a tree-like structure. In other, in order to build a tree, we use the cart algorithm. Cart algorithm. A cart stand for classification and regression tree algorithm. Classification and regression tree algorithm. A decision tree simply asks a question, and based on the answer yes or no, at it further split the tree into subtrees. So now there is the question, why use decision tree? There are various algorithms in machine learning, so choosing the best algorithm for given data set and problem is the main point to remember while creating a machine learning model. There are two reasons for using the decision tree. First one is decision tree usually mimic human thinking ability, okay, while making a decision. So it is easy to understand. Next one is the logic behind the decision tree can be easily understood because it shows a tree-like structure. So this is the easy to understand to all of us. Okay, there are two reasons. Okay, so there are some basic terminology of the decision tree. First one is root node. We all knows about the root node. We already seen in the previous slide. Root node is from where the decision tree starts. It represents the entire data set, which further gets divided into two or more homogeneous sets. Okay. And leaf nodes are the final output node, and the tree cannot be segregated further after getting a leaf node. Okay, because these are the final output node. Splitting is the process of dividing the decision node, or you can say root node, into the sub node according to the given condition. Branches and subtree. A tree formed by splitting the tree. Pruning is a process of removing the unwanted branches from the tree. Unwanted branches from the tree. And parent or child node, the root node of the tree is called the parent node, and the other nodes are called the child node. So these are the basic terminology we can say basic terminology where we can use the decision tree. Just remember all these things. How does the decision tree algorithm works? In the decision tree for predicting the class of a given data set, the algorithm starts from the root node of the tree. This algorithm compares the value of root attribute with records, you can say real data set attribute, and based on the comparison, follow the branches and jump to the next node. Okay. For the next node, the algorithm again compare the attribute value with the other subnodes and move further. It continues the process until it reaches the leaf node of the tree. Okay. So let's we take an example to understand how does the decision tree algorithm works. There is the algorithm we present here. There are some steps we can follow when you have to use the decision tree model. First step is begin the tree with the root node, say as which contain the complete data set. Okay. Second step is find the best attribute in the data set using ASM, attribute selection measure. We will discuss in next slide what is ASM and how can we calculate the ASM. Step number 3, divide the S into subsets that contain possible value for the best attribute. Okay. And next fourth step is generate the decision tree node which contain the best attribute. Step number 5, recursively make new decision tree using the subset of the data set created in the step 3. Continue this process until a stage is reached where you can not further classify the node and call the final node as leaf node. Let's take an example to understand how does the decision tree works. Okay, so suppose there is a condition, there is a candidate who has a job offer and want to decide whether he should accept the offer or not. Okay, to solve this problem, the decision tree start with the root node. What will be the root node? We can select via the ASM. So we select the salary attribute. Okay, so first condition is salary. Salary will be $50. Salary is between if salary is between $50,000 to $80,000. Okay, then we can we can join that. We can accept that offer, or if less than $50,000 salary, then he can decline the offer. Okay, so if salary will be vary $50,000 to $80,000, he accept the offer. Again, we have new node where we can take a decision. You can say the root node is split further into the next decision node. Okay, so next decision node, that means you can say next parameter is distance from the office. Okay, and one leaf node based on the corresponding labels. Okay, so again we check the distance from the office. If it will be nearby from your home, his home, so might be possible he will be join the office, accept the offer. Otherwise, if so far from the home, so it will he will be decline that offer. Okay, so again, if he join the if he want to if office near to the home, he will accept the offer. But here we again the decision nodes here. Okay, the next decision node further gets split into one decision node. uh, there is a provide cap facility cap facility. Okay, there is also one leaf node here. Okay, so again he checked the office provide the cap facility or not. If office providing the cap facility to him, so he will accept the offer. Otherwise, he will not accept the offer. This is the final decision here. The decision node is split into two leaf node where accept offer and decline offer. Okay, you can again consider this diagram to understand the how decision tree works. So what is ASM? While implementing a decision tree, the main issues arise that how to select best attribute for the root node for sub nodes. Okay, so to solve this problem, there is a technique which is called the attribute selection measure, or you can say ASM. By this measurement, we can easily select the best attribute for those node of the tree. There were two popular technique. First one is information gain. Second one is gain index. So we take one of the example. We take one of the example to select best attribute. You can say uh, root node for creating the decision tree using information gain method or gain index method. So first one is information gain. Information gain is the measurement of changes in entropy. Information gain is the measurement of changes in entropy after the segmentation of a data set based on an attribute. Information gain calculates how much information a feature provides us about a class. How much information a feature provides us about a class. According to the value of information gain, we split the node and build the decision tree quickly. A decision tree algorithms always try to maximize the value of information gain, and node or attribute having the highest information gain is split first. It can be calculated by using this formula. Information gain is equals to entropy of S. That means S is the complete data set, minus minus weighted average into entropy of each features. Okay, so that is the formula to calculate the information gain. So what is entropy? Entropy is a metric to measure the impurity in given attribute. Entropy is a metric to measure the purity in a given attribute. It specifies randomness in data, so we can calculate the entropy by given formula. Entropy of S is equals to minus probability of yes log 2 probability of yes minus probability of no log base 2 probability of no, where S is the total number of samples, Probability of S is equals to probability of P of S is equals to probability of S. P of no is equals to probability of no. So second method is Gini index. Gini index is a measure of impurity or purity used while creating a decision tree in CART algorithm. Okay, there is we calculate the purity and impurity, purity and impurity. An attribute with the low Gini index should be preferred as compared to high Gini index. It only creates binary splits, and CART algorithm uses the Gini index to create binary split. So Gini index can be calculated by using this given formula. Gini index is equals to minus is equals to 1 minus summation of j p of j power of 2. Purning, getting an optimal decision tree. Purning is the process of deleting the unnecessary node from a tree in order to get optimal decision tree. With the help of purning method process, we delete the all unnecessary node from your decision tree. Whenever you delete your unnecessary nodes from the tree, you will get obviously optimal decision tree. A too large tree increase the risk of overfitting, and a small tree may not capture all important features from the dataset. There might be the problem. Therefore, a technique that decrease the size of the learning tree with the help of deleting the unnecessary nodes from the tree without reducing accuracy. Okay, there are mainly two types of tree pruning technology here. First one is cost complexity pruning and reduce error pruning. Advantage of decision tree. It is a simple to understand as it follows the same process which a human follows while making any decision in real life. Okay, second one is it can be very useful for solving decision related problem. It helps to think about all the possible outcome from a problem. There is a less requirement of data cleaning compared to as compared to another algorithms. There are some disadvantages also there. The decision tree contains a lot of layers which make it complex. Might be possible it will be happen. Okay, depend on the problem, depend on the data set. It may have an overfitting issues which can be resolved by using random forest algorithms. We will discuss in next slide random forest model. For more class labels, the computational complexity of the decision tree may increase. Let's take an example of the decision tree. With the help of, let's understand the how we calculate the entropy. Okay, and how can we decide the which one is the our root node according to the entropy, calculate entropy. So these are the data set which are D1, D2, D3 information, D4. These are the information entry D1 to D14. That is a play golf data set. Okay, and there are some features like over outlook. There are the three conditions are there in outlook feature: sunny, overcast, and rainy. Okay, next one is temperature. We see here there are three conditions again: hot, mid, and cold. Humidity, high, normal. Only two conditions are there. Wind, true and false. And play, that will be the target, yes or no. Okay. So decision tree example to understand how to calculate the entropy with respect to given feature in order to calculate information gain. Okay, firstly we calculate the probability and entropy of each features and sum of them using this formula. Calculate the probability and entropy of each feature and sum of them. Okay, so T of T of sorry E of entropy of T and X is equals to summation of X, P of X, probability of X, that means features, and entropy of X. Here we try to calculate info gain for each features. Before this, we calculate whole dataset entropy. Firstly, we look at here. First feature, outlook. Okay, outlook having three conditions: sunny, overcast, and rainy. With the help of this column, you can see here outlook is a features name, and there are sunny, overcast, and rainy, three conditions. Okay, and target will be playing golf. Playing golf. That's maybe yes or no at the weather condition outlook. Okay, how many says yes at the time of sunny? Two say yes and three say no. Overcast at the time of overcast, four say yes and zero says no. Rainy at the time of rainy, three said yes and two said no. Okay, so total is 2, 4, 6, and 3, 9, 2, 11, and 3, 14. Okay, so we calculate the whole data set entropy for with the help of this minus this one formula. We're using here this formula. Okay, minus p of yes, you can say probability of yes log base 2 probability of yes minus uh, probability of no log base 2 probability of no. With the help of this, you can calculate the total entropy of total samples. Okay, so we calculate here the entropy of S. Okay, we are talking about here only outlook features. Okay, so we calculate uh, just put it the all value for yes. How many say yes? Total 4 plus 3 7 plus 2 9. 9 upon total. Total means 14. Log base 2 9 upon 14 minus how many says no? Total 5. 3 plus 2 5. 5 upon 14 log base 2 5 upon 14. So that will be calculated log base value and divide and multiplied. You will get the value total entropy 0.94. Okay, for whole data set. Where we calculate entropy of each by given formula. Now we calculate the entropy for each condition. E is equals to minus summation of I of C, I from C, P of I log base to P of I. Okay, so just put it here at the sample to, with condition sunny, as of sunny. That means entropy we calculate here for the sunny condition. Okay, at the loud outlook weather condition, we have three condition outlook features. We have three conditions: sunny, weather, and rainy. So sunny having the value of yes. How many says yes? 2. And how many says no? 3. So we will put it value here minus 2 upon total. Total will be 3 plus 2 5. Okay, minus 2 upon 5 log base 2 2 upon 5 minus how many says no? 3. 3 upon 5 log base 2 3 upon 5. We put it here all values and we will calculate the value. We will get the answer 0.971. For the overcast, for the outlook feature, we have again overcast condition. How many says yes? 4. And how many says no? 0. So that means we will calculate for yes only. Okay. So total will be 4. Okay. So minus 4 upon 4 log base to 4 upon 4. That will be called as 1 minus 0. That will be 0. Okay. So 0 log base to 0. So that will be calculated and you will get the answer 0. Okay. Now, again, we have again condition rainy. So we have the value for yes 3 and for no 2. So total will be 5. Again, put it here in this formula. Okay, minus 3 upon 5 log base 2, 3 upon 5 minus 2 upon 5 log base 2, 3 upon 5, 2 upon 5. Okay, because there are 3 and 2. So you will get the same value 0.971. Okay, so you will we calculated here entropy for each condition. Okay, now we calculate information again on entire data set S. So entropy of play golf on outlook for outlook feature. Okay, so we put it all values in given formula. This one information again is equal to entropy of S minus this one. Okay, we put it here all values in this formula. P of sunny, P of sunny, entropy of 2 for yes, 3 for no. You can check here 2, 3. Okay, plus probability of overcast, entropy of 4 comma 0, because there are 4 for yes, 0 for no. Probability of rainy, entropy of 3 comma 2. All these value given here, and you will put it here. All these value will get the value. You will get the answer 0.6936. Okay. Here entropy of sunny 2 comma 3 you will get 0.97, and probability of sunny will be here 2 upon 3, 2 upon 2 plus 3, total 5, and total will be 14. Okay, so 5 upon 14 here and 4 upon 14 here for overcast, and total is 5. So 5 upon 14 here into these value always already calculated here. Put it here, you will get 0.6936. Okay, so information gain for the outlook attributes, total entropy you have already calculated here for the total sample 0.94. You will get, you will see here from 0.94, and entropy of play at outlook. Okay, you calculated 0.6936. After minus you will get 0.244. Okay, so this is the way to calculate the information gain for particular features. Okay, now we calculate info gain for the temperature attribute. Similarly, we calculate for humidity and wind also. So value of temperature here, condition you can say hot, mild, hot, mid, and cool. Whole data set entropy will be same 0.94, and now we calculate entropy for each value. Similarly, previous process you will get entropy for hot 1.0, entropy of mild 0.9186, entropy of cool 0.8113, and info gain for the temperature attribute. You will use this formula, entropy for S minus play at the time of temperature, entropy of play comma temperature. You will put all these value in this formula, you will get 0.0289. Okay, similarly we calculate for attribute humidity. You will get the answer for humidity 0.1516, and similarly for attribute wind you will we have the value for the wind strong and weak. Total entropy for that particular feature wind, you will get all this. After all this process, all this mathematical work, you will get 0.0478. Okay, all attribute entropy calculated here, and out of all these attribute we check highest info gain. Okay, highest info gain here. outlook attribute have highest info gain. So finally, this is our root node of decision tree, and it's having three values such as sunny, overcast, rainy. There are the branches of that node. Got it? So outlook. How many says positive? 9. And how many says negative? 5. Okay. There are three values, three conditions, sunny, overcast, rainy. Okay. So these are the branches of that particular root node. Okay. So at the time of sunny, 2 said we can play, and 3 said we can not play. Okay. So there are total 5 attribute. Okay. 5 sample. There are 4 sample, but here 4 said we can play at the time of overcast. Okay. So that means you can say next. That means you can say here no one said we cannot play at the time of overcast. That means that will be considered as yes. This is the leaf node. Okay. And again, at the time of rainy time, 3 said positive and 2 said negative. Okay. So again, we follow similarly previous process for that particular node and identify that sub decision node here, and similarly follow that procedure for that right child node. Okay. And we will get the sub decision node here. Okay. After doing all this process, we will get here at the left hand humidity will be the left decision node, humidity having two values, high and normal. You will get here D1, D2, D8 will say no, we cannot play the we cannot play the at the time of high humidity and sunny weather. But D9, D11 said yes, we can play the golf at the time of normal humidity and sunny outlook. That means sunny weather. Okay, this is also clear in previous slide. At the time of overcast, we can play the golf. Okay, and D6, D14 sample, that means they can not play the game according to the uh, condition, and they said no one can play the time of strong wind time and rainy weather. Okay, and D4, D5, D10 said yes, we can play the game at the time of weak wind and rainy weather. Okay, so that's the way to understand the how decision tree works. I hope you all of you understand this thing, decision tree method. Okay.